Right, here I've got an exam question. A student was asked to design a circuit to be used in a street light, and figure 3.3 shows this circuit. I've recreated this circuit here pretty much. The only difference is I haven't got 24 volts, I've got 12 volt DC power supply coming into this breadboard here, just off screen, and that basically is switched on and off by this relay. Now, instead of having three power LEDs in parallel, we've got three 1 watt 3.6 volt LEDs in series here, just off the camera screen here. So you can see them lined up in series with a resistor in line like that. Now, the rated 14 ohms, which I worked out through Ohm's law, calculating the power and then the current and then the voltage, I've just upped it a little bit more because these should be 3.6 volts and 12 divided by 3 is 4 volts. So just, if in doubt, just bring the resistance up if in doubt. But anyway, the point about this, this video is this puppy here, the relay. Now, why do we use it? We've got an electronic circuit here, so there are some transistors here. Now, these paired up like this in this piggyback fashion is called a Darlington pair. Now, you can get that as one component, two transistors in one package like that, and it looks like any other little transistor, if you can just see there. That one is called a 517, and if you look at the data sheet there, you can see it's exactly the same thing. We've got the collector, base and the emitter all in one package there. So you can use it like a normal transistor in that sense. Over here we've got a potential divider. So we've got the sensor here, which is a light dependent resistor. And when I hold my finger over that, the resistance increases, which blocks this way, so the current will go through this way into the Darlington pair. And that gets amplified enough to energize this coil on the relay, which is also protected by a diode just to stop any current going the wrong way. Because you notice if you haven't got the diode on, it can just shudder. I think, like I say, I'm no expert on this, but it might be something to do with back EMF or something that you A-level design engineers don't have to need to know. If you go on and do electronics, I'm sure you'll study that in more detail. So that's it, pretty much. Now, this relay here is the one that we just had in stock, and it is adequate for what we need here. It's a good idea to understand the terminology, and if you're going to look on the side here, we've got an HF46F. If you Google that, you'll find a data sheet, and you'll find a pinout, so that will tell you which legs do which. Now, it didn't quite fit on a breadboard, so I've soldered it onto a proto board, and even then it didn't meet up with the 5mm gaps for each hole here. So I've had to just drill through there to break these two contacts on this strip, which is not very easy to do if you've got a breadboard, because all the columns go in one direction. And if I've got two separate connections in line there, that direction, and then two in line the other direction, it's not very easy to have separate columns like that. So I just had to solder it onto this proto board. When looking up these data sheets, you'll get all sorts of things. You'll find out the coil voltage, so what kind of voltage and current is needed to switch it on. But also the output switch voltage and current, that's important. So these little 1 watt LEDs, we worked out, you know, we're not really using much current here. But if you wanted to power something big like this cordless drill motor, for example, I looked this one up and it is rated at, well, it depends on how much load it's going, but it says 7.2 amps. And this switch current, the max recommended current is 5 amps, so it's a little bit too big for that. You could run a smaller DC motor, so this 12 volt submersible pump, no problem, because it's only 5 watts, so 5/12 of an amp, so it's not going to be an issue running that one. You could even use it to energize a bigger solenoid. So in a minute I'm going to unplug this and use this solenoid in place and give you an idea. In fact, we can do that now. So we'll just pull that out. And now I checked beforehand, this actually draws more current than the coil in this. So they're both the same principle, electromagnetic coil. As soon as you energize it, it attracts this, this pin, this actuator to retract. Now, it is a bit borderline because I measured the resistance on this. And you can just do a little bit of Ohm's law as well to see how much current it will draw. So this has got hardly any resistance. It's almost like a short circuit. It says, let's bear with me, it says 5 ohms thereabouts. Hang on. Yeah, 5 ohms. So that's going to be drawing with a 5 volt, well 4.5 volt thereabouts. It's going to be drawing nearly an amp. Now this little Darlington pair is 800 milliamps. So before running it, I was just going to plug this up. Remember to swap this pin here. So it's normally in there. We put that in the current one like that, and then switch it down. And it did actually say it was drawing less than an amp, so it's okay to run it with this, ran straight away. But if in doubt, put a small resistor in line with it and it should be okay. So this will go into the positive from that end, and then into the collector of the transistor. So hopefully we can just adjust the threshold like that. Yeah, there we go. It runs in the same kind of way like that. So this might be good for a little model actuation of some kind of you know, locking bar. But if you wanted to run a bigger one of these, you'd use a relay as well. So you use the same kind of relay here, and then connect it up to the bigger solenoid on this side. Now, solenoids also come in the form of solenoid valves, and they're really cool if you want to switch on and off some plumbing. So a washing machine, for example, has one of these when the program switches on the part that will allow the water into the drum. It's a solenoid valve, and you can use a microcontroller. You don't have to use this hardwired thing like that. We could use a Genie straight into this. The output's Q0, for example, or Q1, one of the amplified outputs, so it's enough power to shut this. And then you can switch on a much bigger solenoid valve on the other side if it's a washing machine or something like that. Similarly, you might have another relay switching on a bigger motor, for example, because obviously the motor board we've been talking about is fine for little tiny DC motors, but if you want to use a bigger DC motor like this, well, you might even have to specify a bigger relay. So yeah, the terminology to understand with relays is input coil voltage and current, output coil voltage and current. How many poles and throws this is. This is just a single pole, single throw, but as you can see here we've got 2 throws, even though one's not used. So I don't need a dual throw one, but you might do for whatever circuit you have, or more poles. Just like a switch, you can have many different circuits being switched on and off with one coil. And then the output voltage and current, just so that you can make sure it'll handle the load that you're given. Now this one I think is rated up to 250 volts for the so long as you don't have a high current, because it's going to have little wires on it, you can use these for main voltage, although obviously our students won't be allowed to use design any main circuitry in the workshop just for safety reasons, but they can be used to switch on mains, electric things like that. So yeah, useful things, relays and solenoids. Hopefully that video will give you enough of an idea of what you could use them for, give you a bit of inspiration as to what you might want to do with it. Okay, thank you very much.